node 1 via node 2, node 7 to node 8. If we cut or if we remove the nodes, now which node has to be removed? This one. Then comes this one. So all the nodes which are included in the forward path, once they are removed, now see how many loops are left behind in a proper shape. This is no more in a proper shape. This is no more in a proper shape. The outer loop is no more in the proper shape. Only this loop is in the proper shape. So what is actually delta 1? Delta 1 is remove everything, all the loops from this one, all the loops, except the one which is having a true shape. So this is having a true shape, L2. This is L2, which is this one, G3, H2. This means that we remove everything now. So delta 1 is simply this thing. So we have P1. P1 is G5 and we write delta 1 as 1 plus G3 H2. Again, just remove all the nodes which are traversed by the forward path from 1 to G5. Of course, you just leave those two nodes intact, 8 and 1. These are the strong nodes. But the traversing nodes, these are the starting point and this is the end point. End point and starting point has not to be removed. Only the traversing nodes. Now this node is actually traversed. So all the traversing nodes are removed. Now see, only this loop is intact. Every loop is destroyed. So nonetheless, our delta 1 is this one. Now what about delta 2? Let's find out. P2 is G1, G2, G3, G4. Now what is delta 2? Now delta 2, if we remove all this is the other forward path. Now if we remove all the nodes which are traversed from the input towards the output by the path P2. So this is the node it traverses, this is the node it traverses, this is the node it traverses, and of course this is the node. Now this means there are no loops left behind. Nothing. Even this one which was left behind in the first case, that is gone. So there is in fact no loop. So in delta 2, in the expression for delta, you just remove all the nodes and you are left with one only in the expression for delta. So delta 2 is 1 divided by delta. This is a transfer function. So you can simplify this one as G5 plus G3, G5, H2 plus G1, G2, G3, G4, divide by that big expression which you have delta, but no need to write, just put delta. This is the transfer function of this entire system. Now, as a matter of fact, without using Mason's rule, you can even do it, but that in many cases will be a problem. But however, in this case, it's easy. You see, first of all, we can look at the inner loops. Simplify the inner loop, for example, this loop. If you simplify this one, this will be simply equal to which one was that? G1, 1 plus G1 H1 according to the rule. Now this is acting in series with this one. You see, this block is now in series. So we get rid of this block and put G2 over here. So this is the series rule. You are following the cascade or series rule. Now again you end up with a loop. Now this loop is then put as a single block by simplification. So it is G3 divided by 1 plus G3 H2. Likewise this one. So it is G4 H2. G4 1 plus G4 H4. Now these three blocks are in cascade or series. So we simply go for a single block G1, G2, G3, G4 divided by multiplying those together. So let's say this is G6. So we replace these three blocks which are in cascade by a single block which is G6, which transfer function is this. Now those two are in parallel. So we get rid of this one and simply add G5 plus G6 according to the parallel rule. This is in parallel. Now this forms a loop. Now if you are asked to get the equivalent unity feedback system, just leave it. Don't go any further. But however, if you are asked to convert that into a single block, then of course this is a unity feedback. So we end up with G7, which is equal to G5 plus G6 divided by 1 plus H is negative, 1 in this case. So we have simply G5 plus G6. So we end up with a single block. This is G7, and we have R, S on one side and CS on the other side, and G7 will be the same as this entire expression. So whichever is easier, but anyhow Mason's rule is much powerful. It can deal with any of the functions. So this ends up, but anyhow to end the lecture, let's have something else. For example, you are given a transfer function in a single block. This is the transfer function, let's say k divided by s square plus 8s plus k. This is a second order system. Let's take a simple second order system, and we have a single block, and you are asked to convert this into a unity feedback, equivalent unity feedback block. So what you do, you consider this one. This is the transfer function given to you in the block. Now take this entire, the first two terms common. So if we take the first two terms common, you will get something like this. 1 plus k divided by s square plus 8s. Or I can write that one as k divided by s square plus 8s and 1 plus k divided by s square plus 8s. I can write it like this. Now what does it show actually? This one is equivalent to something like this, G1 plus GH. H is 1. So what we do, we simply go for G, which is equal to this one, and that is k divided by s square plus 8s, and we incorporate a summing point, negative feedback of course, and then we have this. However, you can also take s common. So if you take s common, we have s plus 8. So this is the equivalent unity feedback representation of that block diagram. Thank you very much. Allah Hafiz.